Hi guys, welcome to lesson 7.1, 0 and negative exponents. Our objective is that I can simplify expressions involving 0 and negative exponents. And we can extend the idea of exponents to include 0 and negative exponents by when we're decreasing the exponents by 1 is the same as dividing by the base. So for example, if we have 2 and then 2 squared and then 2 to the third and then 2 to the fourth, we're multiplying by 2 every time. If we were to work backwards down our progression there, we would be dividing by 2 every time. So when we got to 0, an exponent of 0, we would divide by 2, and then we would continue to divide by 2 into the negatives. So we have two rules. 0 as an exponent, so we have a to the 0 power, and that is always going to be equal to 1. Anything to the 0 power is 1. Okay, so you might want to highlight that rule. And I will. Anything to the 0 power is 1. Negative exponents, there's two rules here, or two elements of it. We have a to the negative n power is going to be the same as 1 over a to the n. So we just take the inverse, we flip it upside down, we make the exponent positive. And if it is in the denominator, then it just gets flipped up into the numerator. So it'll just be a to the n. All right, so that's two elements of the same rule. Okay, now in simplest forms, any expression that you will write in this class is to be written only with positive exponents. So simplifying the powers, we have 4 to the negative third power, so we can rewrite that as 1 over 4 to the third power. We moved it down to the basement, and we changed it to a positive, so it's happy down there. And we can do 1 to the fourth power, which would be 64, so it'll just be 1 over 64. Sorry, 4 to the third power is 64. All right, so now we have negative 5 to the 0 power. Now notice there are no parentheses around this negative. So that means the only thing that 0 exponent is attached to is the 5 and not the negative sign in front of it. So 5 to the 0 power is 1, and we still have that negative sign, so it's going to be negative 1. Looking down at letter E, this one is one where negative 4 is our base, and it is being raised to the negative 2 power. In letter B, that negative sign is not part of the 5. It is out in front. All right. So letter C, we have 3 to the negative second power, so we rewrite that as 1 over 3 squared, which then equals 1 over 9. And you can just leave these as fractions. All right, I want you guys to try D through F, and then we will go over them. So 6 to the negative first power is just going to be 1 over 6 to the first, or just 1 over 6. We have negative 4 raised to the negative second power, so it'll be 1 over negative 4 squared. Remember, the negative sign is in parentheses. That means negative 4 is being multiplied by negative 4, which is going to give us a positive 16. And 3 to the 0 power, anything to the 0 power is 1. All right, moving down to section 2, or problem 2, we're going to simplify each expression. An algebraic expression is in simplest form when the powers with a variable base are written in only positive exponents. So we need to make these all positive. So x to the negative 9th, we write it as 1 over x to the 9th. Positive exponent. We moved it to the basement. Now it's happy. Well, over here, n to the negative third, it is not happy down in the basement. We need to move it up to the ground floor. So we bring it up to the top, and it is going to be n to the third power. And we don't need to rewrite that 1 there. All right. Letter C. Now we've got 3 elements. We've got 3 parts of our term. We have a 4, we have a c to the negative third, and we have a b. The exponent on the 4 is just a 1, so that's going to remain in the numerator. It's happy where it's at. The exponent for c is negative 3, so we need to put it over c to the third. We need to move it to the basement to make it happy. And the exponent on b is also 1, so we leave that in the numerator. All right, so we only have to move the elements that have a negative exponent. All right, I want you guys to try letters D, E, and F, and then I'll go over them. So letter D, we have y to the negative 2 power. So we rewrite that as 1 over y squared. Letter E, 2 is to the first power, so that remains in our numerator. A is to the negative second power, so it's going to bring it up to the numerator. So it'll be 2a squared. Letter F, n is to the negative 5th power, so we need to put that in the denominator, n to the 5th. But m is also negative, so m will become m to the positive third in the numerator. So for this one, we just kind of flipped their place. All right. Now, problem 3 is evaluating an exponential expression. So we are going to substitute in negative 2 for n and 5 for w. So the first thing, I'm thinking I want to rewrite these with positive exponents only. So we're going to have w to the 0 power, that stays in the numerator. N to the negative 4th is going to move to the denominator and just be n to the 4th. And now I want to substitute in my values. So w is 5, so we have 5 to the 0 power over negative 2 for n to the 4th power. Well, 5 to the 0 power is 1. Negative 2 times negative 2 times negative 2 times negative 2 is a positive 16. Okay. For letter B, let's rewrite that using positive exponents only. So n to the negative 1, we need to move that into our denominator. So we have n to the first power, and we have a w squared. So what do we need to put up in the numerator? We're just going to leave a 1 there. And because we moved all of the terms out, and we can imagine there's an imaginary coefficient of 1 in our numerator, so that stays behind. So now we need to substitute in our 2 values. So we have 1 over n to the first power is just going to be n, so that's negative 2 times 5 squared. So we have 1 over negative 2 times 5 squared is 25. And this is going to equal 1 over negative 50. Or if you put the negative sign just in front of the entire fraction, that's fine. Okay. I want you guys to try letter C and D on your own, and then check your answers with me. So n to the 0 power, w to the 6th power, those are already where we need them to be. They're already positive exponents. So we're going to substitute in our values. We have negative 2 to the 0 power over 5 to the 6th power. Anything to the 0 power is 1. 5 to the 6th power is 15,625. Okay, letter D, 1 over n to the w negative 1. So w to the negative first power, we need to move that into our numerator. So we're going to write w to the first, or just w, over n. And when we substitute in 5 for w and negative 2 for n, That is our final answer, -5/2. All right. Problem 4, using an exponential expression. So now we're going to be dealing with word problems where we're going to have to be substituted. So we have a population of insects that triples every week. The number of insects is modeled by the expression 5,400 times 3 to the w power, where w is the number of weeks after the population was measured. Evaluate the expression for w equals -2, 0, and 1. What does each value of the expression represent in the situation? So let's just start with, we have 5,400 times 3 to the -2 power, so we'll just start with that one. And that's going to be, we need to rewrite it with positive exponents, so 5,400 over 3 squared, which is 5,400 over 9, or 600 insects. And since this is -2 and w is the number of weeks after the population was measured, this would be 600 insects 2 weeks before measuring. Okay, so that is a prediction of what would have happened 2 weeks before we measured in order to get the population where we are today of 5,400. So now we have our second one, 5,400 times 3 to the 0 power, because we're going to use w equals 0 now. And that's going to be 5,400 times 1, which is just 5,400 insects when measured. Because we are not afterwards, our w is 0. We have not let any time pass yet. So it is 5,400 insects when we are measuring. So the last one is w equals 1. So we have 5,400 times 3 to the first power, which is 5,400 times 3, and that is equal to 16,200 insects 1 week later. Okay, so 1 week after we measured, our population went from 5,400 to 16,200. I want you guys to try letter B on your own, and then I will go over it. So, a population of birds doubles every 8 years. The expression 6,400 times 2 to the t power models a population of 6,400 birds after t periods of 8 years. Evaluate the expression for t equals 0 and t equals -2. Describe what each value represents in the situation. So let's just start with t equals 0. So we have 6,400 times 2 to the 0 power, which is 6,400 times 1, which is 6,400 birds when measured. So the day we measured them, there were 6,400 birds in this population. So now we need to use our second value for t, which is -2. So we have 6,400 times 2 to the -2nd power. Well, let's rewrite that with a positive exponent. So we have 6,400 over 2 squared, which is 6,400 over 4, or 1,600 birds. And we want to know how many years before. So t was how many periods of 8 years. So for -2t is t, that means 2 cycles have gone by. So that was 16 years ago. So 16 years ago, there were 1,600 birds in that population. And then today, there are 6,400 birds in that population. All right. Last section for the notes for today is actually problem 5. I wrote it as problem 5, but this really comes out of 7.2 and 7.3. It is simplifying an expression with products that involve negative numbers. So we are using our power rule and product rule again that we learned yesterday, and we are simplifying. So first thing, we have -4 being distributed to the 6th. Remember, when it's power to a power, we multiply our exponents. So it's going to be y squared x to the -24th power, which when we rewrite using only positive exponents is going to be y squared over x to the 24th. This is your final answer. Okay. Letter B, we have a product being raised to a negative power, so we need to make sure we apply that exponent to each of our exponents that are within our parentheses. Remember, if nothing is written there, we assume that it is an exponent of 1, so it's 2 to the first power and z to the first power. So when we multiply, we have 2 to the -4th and z to the -4th. We want to rewrite both of those with positive exponents, so we'll leave a 1 in the numerator, and we have 2 to the 4th, z to the 4th, which we can reduce to 1 over 16 z to the 4th. Okay. I want you guys to try, well, they got labeled letters D and E, so try letters D and E on your own, and I will go over them. So for letter D, we need to apply the exponent of 4 to our product, which would be 3 to the first and g to the -2nd. So we'll have 3 to the 4th power, g to the -8th power. And I want to rewrite those using positive exponents only. So we have 3 to the 4th over g to the 8th. And when I calculate 3 to the 4th, 3 times 3 times 3 times 3, that is 81 over g to the 8th power. That is your simplified form. Okay. Letter E, we have a power to a power, so we have -3 times 3. So we have x to the 4th, y to the -9th. We want to rewrite that using only positive exponents. So we have x to the 4th over y to the 9th. Okay. Make sure you're filling out your level of understanding. 1 being I'm lost, 4 being I could teach this lesson. If you are getting parts of it wrong, you probably shouldn't be circling 4, because that means you're probably not at the point where you could teach this lesson to somebody. Okay, write down any confusion or questions you may have from the lesson, and make sure you fill in that summary in your own words, what we learned today. All right, have a great day, and I will see you in class.